Hello guys, I am Pavni Chaturvedi and in my previous video I have already discussed about chapter 1 motion from class 9th physics book. We have already discussed that what is motion, what is displacement and what is distance. In this part I am gonna discuss about two topics, uniform motion and non-uniform motion and speed. Let's start with uniform motion and non-uniform motion. A body has a uniform motion if it travels equal distances in equal intervals of time, no matter how small these time intervals may be. For example, a car running at a constant speed of say 10 meters per second will cover equal distance of 10 meters every second. So its motion will be uniform. Please note that the distance time graph for uniform motion is a straight line, as when this is y-axis and this is x-axis. Y-axis denotes distance and x-axis denotes time. Now, when the straight line is going between equal in between x-axis and y-axis, then we say that the motion is uniform. Then this straight line denotes the uniform motion. A body has a non-uniform motion if it travels unequal distance in equal intervals of time. For example, if we drop a ball from a roof of a tall building, we find that it covers unequal distances in equal intervals for time. It covers 4.9 meters in the first second, 14.7 meters in the second, and 24.5 meters in third second, and so on. Thus, a freely falling ball covers similar smaller distances in the initial 1 second intervals and larger distances in the later 1 second intervals. From this discussion, we conclude that the motion of a freely falling body is an example of non-uniform motion. The motion of a train starting from a railway station is also an example of non-uniform motion. This is because when the train starts from a station, it moves a very small distance in the first second. The train moves a little more distance in the second, and so on. And when the train approaches the next station, the distance traveled by it per second decreases. The distance time graph for a body having non-uniform motion is a curved line. So when the bar this graph have a curved line, so this means the motion is not uniform. Okay. Thus, in order to find out whether a body has uniform motion or non-uniform motion, we should draw a distance time graph for it. If the distance time graph is a straight line, the motion will be uniform, and if the distance time graph is a curved line, the motion will be non-uniform. It should be noted that non-uniform motion is also called accelerated motion. Now, motion of a body can be described by three terms: speed, velocity and acceleration. So as I told you already that we are gonna discuss about speed in this part. So now let us see what is speed. If a car is running slow, we say that the speed is low, and if the car is running fast, then we say that its speed is high. Thus, the speed of a body gives us an idea how slow or how fast that body is moving. We can now define the speed of a moving body as follows. Speed of a body is the distance traveled by it per unit time. And the speed of a body can be calculated by dividing the distance traveled by the time taken to travel the distance. So the formula for speed will speed is equals to distance traveled upon time taken. So this is the formula of speed. Okay. Suppose now we are going to solve one problem, that suppose a car travels the distance of 100 kilometers in 4 hours. The speed of the car will be, okay, this car is moving 100 kilometers per 4 hours. 4 hours. So we have to find the distance traveled by a car, the speed of the distance traveled by a car. So the distance, the formula of speed is distance upon time. So according to the formula, 100 kilometer upon 4 hour will be the speed. So we when we calculate it, so the speed of the moving car will be 25 kilometers per hour. So this is how we calculate the speed of a moving body or a moving object. Okay. So we have find how we can calculate the speed of a moving object. Now, what is the SI unit of speed? We know that the formula of speed is distance upon time, right? So the SI unit of speed will be, according to this formula, we are going to calculate the we are going to know about the SI unit of speed. As we know, the SI unit of distance is meters. The SI unit of distance is meters and the SI unit of time is seconds. So we can, the meter is also denoted as small m, and seconds can be denoted as small s. So ultimately the SI unit of speed will be SI unit of speed will be m upon s. Is that easy? Or we can also write it as ms raised to the power minus 1 according to SI unit of speed. Now, okay, as speed has magnitude only, it has no specific direction, therefore speed is a scalar quantity. Whereas if we talk about velocity, then velocity has magnitude as well as specified direction, then it is a vector quantity. So the speed of a running car at any instant of time is shown by an instrument called speedometer. Like here it is made that speedometer look like this, and which is fixed in the car. The speedometer gives the speed in kilometers per hour. The distance traveled by the car is measured by another instrument called odometer, which is also installed in the car. It records the distance in kilometers. Now we are going to now we are going to discuss about average speed. Now we know that what is speed. Now we are going to know what is average speed. The average speed of a body is the total distance upon the total time taken. So we can so the formula of average speed, to calculate the average speed, is total distance traveled upon total time taken. So this is the formula to calculate the average speed. So we know the formula of average speed. Now we will discuss what is actually the average speed. While traveling a car or a bus, we have noticed that it is very difficult to keep the speed constant or same, because at many places the brakes are to be applied to slow down or stop the car due to various reasons. Thus, the speed of the body is usually not constant or not uniform value, and the distance traveled divided by time given. Thus, the speed is not constant. Distance traveled divided by time gives us the average speed during that time. For example, for a car which travels a distance of 100 km in 4 hours, the average speed is 100 upon 4, which is 25 km per hour. Although the average speed of this car is 25 kilometers per hour, it does not mean that the car is moving at this speed all the time. When the road is straight, flat and free, the speed may be much more than 25 kilometers per hour, but on the bent, curved road, hills or in a crowded area, the speed may fall well below this average value. Okay, now we know what is average speed and what is the formula of average speed. Now we are going to discuss what is uniform speed or constant speed. A body has a uniform speed if it travels equal distances in equal intervals of time, no matter how much small these time intervals may be. For example, a car is said to have a uniform speed of say 60 kilometers per hour if it travels 30 kilometers every half hour, 15 kilometers every quarter of an hour, 1 kilometer every minute and 1 upon 60 kilometers every second. As we have already discussed above, in practice, of, actual practice, the speed of a body rarely remains uniform or constant for a long time. If however the speed of a body is known to be constant, uh, we can find out exactly how much distance it will travel in the given time, or if we know the distance traveled by the body, we can calculate the time taken to travel that distance. We will now solve some numerical problems based on speed. Suppose, okay, suppose a scooterist covers a distance of 3 kilometers in 5 minutes. 3 kilometers per 5 minutes. Okay. So, first part is find the speed of the scooterist in centimeter per second. centimeter per second. Now we are gonna convert this, convert 3 kilometers in centimeter and 5 minutes in second. So we know 1 kilometer has 1000 meters. So 1 meter, and 1 meter has 100 centimeter. So yeah. So we know that 5 kilometers, which means 5 kilometers is 5000 meters, and 5000 meters is how much centimeters. So we will know that how 5000 meter is equals to, we will add two zeros, uh, to 5000. So this is, it was 3, sorry. So we got 3 lakh, 3 lakh centimeters, and converting 5 minutes in seconds. So now we will convert 5 minutes in seconds. So 1 minute has 60 seconds. So 5 minutes have 300 seconds. Now we got the values, this and this. So we can easily calculate the speed of these two values in centimeter per second. Now, as we all know, this the formula of speed is distance upon time. So this speed will be 3 lakh upon 300. We will also mention the units like this. So we will cancel out 2 zeros with 2 zeros. 1. So this will be the speed. So the speed of a scooter is, according to centimeter per second, is 1000 centimeter per second. Now the second part is meter per second. We will convert 3 kilometers in meters and 5 minutes in seconds. 3 kilometers, like see, 1 kilometer has 1000 meters. So 1 meter, so 3 kilometers, sorry. 3 kilometer will have 3000 meters. Same here, 1 minute has 60 seconds. So 5 minutes will have 30 seconds, 300 seconds, sorry. We can easily now calculate the values, or we can easily calculate the speed. So the speed will be 3000 upon 300. Do not forget to mention the units. Now we cancel out 2 zeros with 2 zeros. The speed will be 10 meter per second. Now we have calculated the speed. Now here comes the third part, kilometers in 1 hour. Per hour, I mean. So kilometer is already written, so we have to convert this into hours, or we can directly use this also after it. So 3 kilometers is as it is. Now convert this into hours. Now this will be 5 upon 60, because 60 denotes hours and this is a minute. So this is the fifth part of 60. which is as it is minutes. No? So we are going to, which is 0.082 hours. If we calculate this, we got this value. So 5 minutes are 0.082 hours. So now we will calculate the speed. Distance upon time. So we ultimately know that distance was 3 kilometers upon 0.082 hours. And if we calculate this, we will get approx idea of the speed, which is 36 kilometers per hour. So this is how we will calculate the speed. And let us take one more question to learn more about how to calculate the speed. Okay, suppose the train A traveled a distance of 120 kilometers. Train A covers 120 kilometers per 3 hours, and train B covers 180 kilometers per 4 hours. So the question says that which train travels faster. So we will first find the speed of train A and then train B. So let us calculate it. 120 upon 3. So it is 40 kilometers per hour. ट्रेन ए का स्पीड आता है 40 किलोमीटर पर आवर एंड ट्रेन बी का 180 kilometers. Please don't forget to mention the values. Kilometers and 4 hours. So which is 40, when we calculate 180, when we divide 180 by 4, we get 45 kilometers per hour. Now we can exactly know which train is faster. Train B is faster because it is traveling 45 kilometers per hour, but train A is covering 40 kilometers per hour. This is how we can compare the speeds compare the speeds of two traveling or two bodies which are in motion. So thank you, and please subscribe my father's channel and push the bell icon and select the option of all. Now I will meet you in part 3 with velocity. I will discuss velocity and some more points and some equations and some problems. Till then, stay safe, stay at home. Thank you.